Shocking, unbelievable, and possibly history-changing. NASA has confirmed the detection of new organic molecules in the hidden ocean of Saturn's moon Enceladus, and this discovery is sending shockwaves through the scientific community and beyond. What was once considered a frozen, lifeless world is now emerging as one of the most promising places in our solar system to search for life. Not in the distant future, not in science fiction, but right now, based on real data, real measurements, and real chemistry, detected hundreds of millions of kilometers away from Earth. Enceladus is not a planet. It is a small icy moon, barely 500 kilometers wide, orbiting the gas giant Saturn. For decades it was just another frozen object in the outer solar system, cold, silent, and seemingly unremarkable. But beneath its cracked, gleaming white surface lies something extraordinary. A vast global ocean of liquid water, hidden under kilometers of ice, warmed by tidal forces, and now confirmed to contain complex organic molecules that are essential ingredients for life. The story of this discovery begins with NASA's Cassini spacecraft, one of the most ambitious and successful planetary missions ever launched. Cassini spent 13 years exploring Saturn and its moons, sending back breathtaking images and revolutionary data. But among all its discoveries, none may be more important than what it found at Enceladus. In 2005, Cassini made a shocking observation. Jets of water vapor and icy particles were erupting from cracks near Enceladus's south pole. These cracks, later named tiger stripes, were acting like giant geysers, blasting material from the moon's interior straight into space. This was unprecedented. No one expected a small icy moon so far from the sun to be geologically active. As Cassini flew through these plumes, its instruments analyzed the material directly. What they found changed everything. The plumes contained water vapor, ice grains, salts, hydrogen, carbon dioxide, methane, ammonia, and simple organic compounds. This was not just frozen ice. This was chemistry, active, dynamic, and complex. Over the years, as Cassini continued its close flybys, scientists realized that the plumes were coming from a liquid ocean beneath the ice. A global ocean, in contact with a rocky core, heated by tidal forces as Enceladus is squeezed and stretched by Saturn's gravity. This combination of liquid water, energy, and chemistry matched the basic conditions thought necessary for life. But the most shocking confirmation came later, after years of careful analysis of Cassini's data. NASA scientists announced the detection of complex organic molecules in the plumes, molecules far larger and more intricate than anything previously observed on Enceladus. These were not simple carbon compounds. These were macromolecular organics, rich in carbon and hydrogen, similar in complexity to those found in meteorites and even in Earth's oceans. These molecules were detected by Cassini's cosmic dust analyzer, which studied tiny ice grains ejected from Enceladus's ocean into space. When these grains slammed into the detector at high speed, they vaporized, allowing scientists to analyze their chemical fingerprints. The results were stunning. The data revealed organic compounds with molecular masses of over 200 atomic mass units, suggesting long chains and ring-like structures. In simple terms, Enceladus's ocean is not just salty water. It is chemically rich, active, and potentially habitable. One of the most important discoveries was molecular hydrogen in the plumes. Hydrogen is a powerful energy source for life. On Earth, deep-sea hydrothermal vents release hydrogen that microbes use to survive without sunlight. The presence of hydrogen at Enceladus strongly suggests ongoing hydrothermal activity at the ocean floor, where hot water interacts with rock, producing energy-rich chemical reactions. This means that Enceladus may have hydrothermal vents, just like Earth's deep oceans. And on Earth, these environments are teeming with life. The implications are enormous. For decades, scientists believed that life could only exist in a narrow habitable zone, around stars, where liquid water can exist on a planet's surface. Enceladus destroys that idea. It shows that life could exist in hidden oceans, warmed by gravity, far from any sunlight. NASA's confirmation of new organic molecules pushes Enceladus to the top of the list of places to search for extraterrestrial life. Not Mars, not even Europa alone. Enceladus stands out because it is actively spraying its ocean into space, offering scientists a direct way to sample its interior without drilling through kilometers of ice. This discovery forces us to confront a profound question. If Enceladus has liquid water, energy, and complex organic chemistry, then what is stopping life from existing there? Scientists are careful. They do not claim to have found life. but they are increasingly confident that Enceladus has all the ingredients necessary for life as we know it, and where there are ingredients, nature has a way of experimenting. The organic molecules detected are thought to form through chemical reactions between water and rock at high temperatures. These reactions produce complex carbon-based compounds that can serve as building blocks for amino acids, lipids, and other molecules essential for living systems. On Earth, similar processes may have played a role in the origin of life. Deep-sea hydrothermal vents are considered one of the most likely places where life first emerged. If Enceladus has similar environments, it could represent a parallel experiment in biology, occurring independently of Earth. Imagine what that means. A second genesis of life within our own solar system. The confirmation of these molecules also raises questions about how common life might be in the universe. If a small moon around a gas giant can host a potentially habitable ocean, then how many similar worlds exist elsewhere? There are hundreds of icy moons in our solar system alone. Beyond it, there may be countless exomoons orbiting distant planets. Enceladus teaches us that life does not need a planet. It does not need sunlight. It needs water, energy, and chemistry. And those conditions may be far more common than we ever imagined. NASA scientists emphasize that the detected, organic molecules are not contamination. Cassini was carefully designed to avoid carrying Earth-based organics that could confuse results. The data has been independently verified, analyzed, and reanalyzed by multiple teams across the world. This is not speculation. This is evidence. The next step is clear. We need to go back to Enceladus. Several mission concepts are already being discussed. Future spacecraft could fly through the plumes with more advanced instruments, capable of detecting amino acids, lipids, and even potential biosignatures. Some concepts involve orbiters. Others propose landers near the South Pole. More ambitious ideas include sample return missions, bringing material from Enceladus back to Earth for detailed laboratory analysis. Such missions would be incredibly challenging, expensive, and risky. But the potential reward is unparalleled. Discovering life beyond Earth would be one of the greatest scientific achievements in human history. Even if no life is found, Enceladus would still revolutionize our understanding of chemistry and planetary processes. It would show how complex organic molecules can form and persist in extreme environments, reshaping theories about the origin of life. There is also a deeper, more philosophical impact to this discovery. For centuries, humans have wondered whether we are alone in the universe. Every new discovery brings us closer to an answer. Enceladus whispers that life may not be rare, that it may emerge wherever conditions allow, even in the darkest, coldest corners of space. When we look at Enceladus, now we no longer see a frozen moon. We see a dynamic world, with a beating chemical heart beneath its icy shell, a world that is alive with possibility. Saturn's rings may be what capture our eyes, but Enceladus captures our imagination. Beneath its frozen surface lies an ocean that could rival Earth's in volume, an ocean that may have existed for billions of years, an ocean that now, undeniably, contains complex organic molecules. NASA's confirmation marks a turning point. It is a reminder that the universe is more surprising, more creative, and more alive than we ever expected. And somewhere, deep beneath Enceladus's ice, in a dark ocean warmed by unseen forces, chemistry is happening. Molecules are forming, energy is flowing, and nature may be taking steps toward life.